Hello, my name is Ahmed Etefy. My contribution to this project was to connect all the outputs of the car to the Arduino. So in this project we have two outputs, motors and a buzzer. Let's start with the motor. Now we only have two motors and a flexible moving marble in the front. So we move the car forward. So to move the car forward, we just turn both motors on, and this moves both wheels. But what do we do when we want to move the car to the left or to the right? The answer lies in providing different polarities to the motor. What we mean by that is, depending on the direction we want, we send different signals to the motor. To give you an example, let us say that we want to move the motor to the right. We then would expect the right wheel to move backwards and the left wheel to move forwards. To be able to control the motion of the wheels by providing different polarities, we need a certain extra piece of equipment called an H-bridge or a motor driver. What the H-bridge does is control the signals sent to the motor, and hence by control the motion of the wheels through manipulation of the code. So H-bridge, also known as the motor driver, is the intermediary between motors and the Arduino. Let's get to the connections part. Each motor has its own separate H-bridge. An H-bridge has a 12-volt socket and a ground socket. We connect the positive end of an outside power source, in this case we used batteries, to the 12-volt socket and connect the ground to the ground series connection on the breadboard, obtained by taking a male-to-male from the ground socket in the Arduino to a socket in the breadboard. Next is we use the three digital pins from the H-bridge of both motors, and these correspond to enable A, input 1 and input 2. Through manipulation of the code by sending different signals to input 1 and input 2, we can move the motor and hence by the wheel in different directions, clockwise or counterclockwise. Okay, so as for our other output, we use the buzzer. What the buzzer basically does is emit a sound when it's given a high voltage, and emits nothing when it's given a low voltage. The buzzer has two pins, the ground and the output. We connected the ground pin of the buzzer to the ground socket in the breadboard, which is connected in series to a male-to-male jumper that goes from the breadboard to the Arduino. And we connect the other pin of the buzzer to digital pin on the Arduino, and hence by manipulated in code, sending a high signal when we want the buzzer to go off, and a low signal when we want the buzzer to stop. Thank you.
Hi, I'm Sara Ashraf, and I will be talking about the second input of our project, which is the line tracker sensor. Our car detects black tape in which it moves on. Therefore, the line tracker sensor is used to detect if there is a black tape underneath the car. We use two different types of line trackers, but before we get into that, let's talk a little about some of the line trackers' background. Line tracking sensors allows the robot to tell objects or surfaces apart, based on how dark or how light they are. It shines a beam of infrared light out onto the object, and measures the amount of light reflected back. And now let's discuss the two types of sensors that we used in this project. First is a digital sensor, which has 4 pins: VCC, ground, D0 and A0. VCC is what provides voltage to power the sensor so that it can read the inputs. It is connected to a 5-volt socket in the Arduino through connecting it to a socket in the breadboard, which is connected in series with a male-to-male jumper with one end in the breadboard and the other in the 5-volt socket in the Arduino. As for the ground pin, it is connected the same way as the 5 volts. It's connected to a socket in the breadboard, which is connected in series to a male-to-male jumper with one end in the breadboard and the other in the ground socket of the Arduino. We connected the D0 pin to a digital pin socket on the Arduino and manipulated the input we get through the code in order to direct movement of the car. We placed two of these on the edges of our car, one on the left edge and the other on the right edge, to detect the motion of the car if it needs to be sideways. For example, let us say there is a black tape under the left edge of the car. Then we should read the signal and send the appropriate output signal to the motor to move left. As for the other type of sensor, we used an analog line tracker, which is connected the same way as the digital one, and functions the same way the other line trackers function, except that it uses an analog pin in the Arduino.
Hi, I'm Heba Hegazy. I'm going to introduce the inputs we have in our car project. Actually, you have two inputs, which each control the movement of the car in one way or the other. My contribution was setting up the ultrasonic sensor. I start with a little background on the ultrasonic sensor. According to its definition, it's technology based on the principle that sound has a relatively constant velocity, and the time for an ultrasonic sensor's beam to strike the target and return is directly proportional to the distance of the object. And hence, by striking a beam towards an object and timing the interval till it gets back, we find the distance of the nearest obstacle in the sensor's scope. So, from the definition, we use the ultrasonic sensor technology to detect obstacles in the car's way and send the appropriate signals to the car to prevent it from colliding with the obstacle by stopping the motor movement and alarming us through a buzzer. The ultrasonic sensor has 4 pins. We use only 3 of them, the VCC, ground, and echo. VCC is what provides voltage to power the sensor to be able to read inputs. The VCC is connected to the 5 volts socket in the Arduino through connecting it to a socket in the breadboard that's connected in series with a male-to-male jumper, with one end in the breadboard and the other in the 5-volt socket in the Arduino. As for the ground pin, it's connected the same way the 5 volts is connected. It's connected to a socket in the breadboard that's connected in series to a male-to-male jumper, with one end in the breadboard and the other in the ground socket in the Arduino. As for the echo bin, it's connected to a digital bin in the Arduino, and through code manipulation, we can find the distance from the ultrasonic.
Hello, my name is Youssef Adel. I was responsible for manipulating the code that takes the inputs and produces outputs seen in the movement of the car and the noise of the buzzer. In a nutshell, first thing we do is define our pins. By defining our pins, I mean giving them names for easier access later on in the code. Then we have the setup function. The setup function is called only once during the program run. What it does basically is define the pins which are going to be inputs and which are going to be outputs. First, we use the serial begin command, which takes an integer that translates to how much time the program should take before beginning. The rest of the commands are pin mode commands, which are basically utilized to tell us which pins are inputs and which pins are outputs. Next, there is the loop function. The loop function keeps on going, called on and on, as long as the power is connected to the Arduino. We'll begin our loop function with an if-else statement. The if statement checks whether the reading of the ultrasonic pin reads an object that is closer than 5 centimeters. If yes, it sends a high output signal to the both in1, in2 pins of motors, which makes them stop. Also, an output signal is sent to the buzzer to put it off to alarm whoever is in charge. If no object is within 5 centimeters of our car, we enter the else statement that in turn has 3 if conditions. First condition checks if there's a signal, if there's a black tape under the middle line tracker of our car. If yes, both motors will move forward. The second, if no, we move on to the next if condition. The if condition checks whether the black tape under the line tracker of the left edge of the car is visible. If yes, left wheel moves backwards and right wheel moves forward. This is done through sending different polarities through manipulation of the code. Finally, we check for the last condition, which checks if there's a black tape under the right sensor. If there is a black tape under the right sensor, If there is a black tape under the right sensor, we move the car rightward by moving right wheel back and left wheel front. This process then repeats all over again.
Like we mentioned before, in our car project we have 3 sensors which detect black tape. The middle sensor, the left sensor, and the right sensor. And with the inputs we get from these sensors, we manipulate the direction of the car movement through code, of course. Okay, so let's take a look at what happens. We can see on the screen the word white. This means that our middle sensor only reads white, which means there's no black tape under it, so nothing will happen. Okay, so let's see what will happen if there's a black tape under the middle sensor. Okay, to begin with, let's put a black surface underneath the middle edge, or the middle sensor. Okay, let's take a look at what happens to the movement of the car. And as we can see, the car moves forward, both the left wheel and the right wheel move forward. Okay, let's say at any instance of time, an obstacle is in the direction of the movement of the car. As we can see, the car stops, both wheels stop, and a buzzer is given off. Okay, let's say we remove the obstacle. The car moves in its direction like it's supposed to be. Pause. Now let's take a look at what happens when a black tape or a black surface is found underneath the left sensor, on the left edge of the car. Okay, so let's place a black surface. First of all, okay, now let's take a look at what happens when we want the car to move to the left. Let's say at any instance of time we put a black surface underneath the left sensor, and let's take a look at what happens. Okay, first on our screen, the sentence "left is black" is printed out, and this means that our code reads that the car should move to the left, and will print outputs based on that. Okay, let's take a look. So the right wheel moves forward and the left wheel moves backwards, and this is to make room for the car to move leftwards. Okay, let's say at any instance of time, there's an object in front of the car. When we want the car to move again, we'll just remove the obstacle. And the movement is back on. Pause. So for our final part, we're going to show you what happens when we want the car to move rightwards, and by that we mean there's a black tape underneath the right edge of the car. Okay. So we look at what happens to the wheels. As we expect, the right wheel moves backwards and the left wheel moves forward, and this gives room for the car to move rightwards through this flexible moving marble. If we take a look at the screen, we can see that there's the string "right is black" printed out, and let's say at any point of time, if it's working, yes, and we put and there's an obstacle in front of the car, the movement stops until we remove the obstacle, and then the car continues its motion. Okay, thank you.